Hello guys, you are welcome. Now in this video we will cover the multiplication of polynomials. And please, if you haven't done so already, please do well to subscribe to this channel. Thank you very much. Now let's head into the business of the day. In dealing with the multiplication of polynomials, there are certain laws I'd like you to be conversant with. First of all, let's deal with one of the laws of indices. We'll just pick one of them, and which is a raised to the power b times a raised to the power c is equal to a raised to the power b plus c. Now, in order for this to hold, the bases must be the same, which is a and a. And then when it is multiplication, you add the powers. Let's try that with an example. Let's say x raised to the power of 3 times x raised to the power of 2. Now, the bases are the same. That is x, that's a variable. So now, what we'll have is x raised to the power of 3 plus 2, which should give us x raised to the power of 5. So let's do this in basic form. Let's just, you agree with me that your x cubed is equal to x times x times x 3 times. And then your x squared is x times x. So in saying x cubed times x squared, you're basically just saying x times x times x, which is for the x cubed, times x times x, which is for the x squared. By the time you expand this, what you have is x times x times x times x times x, which is equal to x raised to the power 5. That's what it is basically. So now the second thing I would like you to take note of is the this is not under the law of the indices, but take note of this. It's the distributive nature of multiplication. We call it distributivity. Now, if you are given, say, 2a plus b, this, because multiplication is distributive, you are multiplying this 2, you are finding the product of this number 2 and the algebra, the expression in this bracket. So multiplication is distributive in the sense that this 2 will go into this expression and multiply every term, every element in this expression. So that becomes 2a plus 2b. This 2 is distributed amongst every member of this expression. Now let's try something else. Say a plus b, c plus d. Now, because of the distributive nature of multiplication, every element in this expression will be distributed amongst this whole expression. How do we accomplish that? This becomes a into c plus d, and then plus b into c plus d again, so that every term here is distributed to each term inside here. That's the whole concept of multiplication. So this becomes ac plus ad plus bc plus bd. So that's that on the distributive nature of multiplication. And finally, take note of the associative nature of multiplication. Call it associativity. So a times b times c is also equal to ab times c. That is, you can multiply ab first, a and b first, and then later multiply by c. And this is also equals to a times b c. That is, you find the product of b and c first, and then multiply by a. So that's that. Just take note of those, and you'll see how we'll apply them in some examples. Now let's head into some examples. Example 1. The first polynomial is 2x cubed minus x squared plus x minus 1. We have to multiply it by 3 minus 2x. So simple. You distribute every guy here into every guy in this polynomial into this polynomial. I'm using that word guy too much. You multiply every term in this polynomial into this polynomial. So let's do that. 2x cubed goes into 3 minus 2x. And while you're doing this, you are taking your signs. Minus x squared into 3 minus 2x plus x into 3 minus 2x. And then finally, minus 1 into 3 minus 2x. So now you expand. This goes into this 2x cubed times 3. We have 6x cubed. 2x cubed minus 2x. And you have minus 4x cubed times x. We give us x raised to the power of 4. Minus x squared times 3. You have minus 3x squared. Minus x squared times minus 2x. You have plus 2x cubed. Remember, negative times negative is positive. So x times 3, you have plus 3x. X times minus 2x, you have minus 2x squared. Minus 1 times 3, you have minus 3. Minus 1 times minus 2x, you have plus 2x now. So what we do next is we collect like terms. So we start from the highest power. We'll place that down first. Remember the standard form of expressing polynomials. So this is minus 4 raised to the power of x, minus 4x raised to the power of 4. So the next power is plus 6x cubed. Is there any other x cubed? Yes, we have this. So we have plus 2x cubed. Any other x cubed? No. So we'll move on to the next term. Minus 3x squared. Any other here? Minus 2x squared. Any other x squared? No. So we move on to x. We have plus 3x plus 2x. Move on to the constant. We have only one constant, which is minus 3. So this stands alone. 6x cubed plus 2x cubed gives us 8x cubed. Minus 3x squared minus 2x squared gives us minus 5x squared. Then 3x plus 2x gives us 5x and minus 3. So that's our answer for that. Now let's take another example. In this case, we are given 2x minus 1, 3x plus 2, then x plus 5. So this here is where the associativity of multiplication comes in. So we'll pick just two expressions, multiply them first, and then the product will now be multiplied by the third one. So let's start with this first. Let's put it in a huge brace. So let's distribute 2x minus 1 into 3x plus 1. So you have 2x into 3x plus 2. Then you have minus 1 into 3x plus 2. Close that bracket. And then we close the brace. All of that will be multiplied by 2x plus 5. So we expand this, you have 2x times 3x gives you 6x squared. 2x times 2 gives you 4x. Minus 1 times 3x gives you minus 3x. Minus 1 times 2 gives you minus 2. So now we have that. Then multiply. First of all, let's simplify this. This becomes 6x squared. 4x minus 3x gives us x minus 2. So we have x plus 5. So now we multiply this again. In I should have talked about the commutative nature of multiplication also. Let me just do that. Commutativity. Commutativity. It's simply this. A times B is equals to B times A. That's what commutativity is. So this guy is also equal to. You don't necessarily need to do this, but I just feel you should know this. So why am I doing that? Because I want to distribute this guy into this guy instead of distributing this guy into this guy. Why? It's not a law. This will just make my work look less messy. So let's distribute x plus 5 into this other polynomial. So this is x into 6x squared plus x minus 2, then plus 5 into 6x squared plus x minus 2. So x into this, x times 6x squared gives us 6x cubed. X times x is x squared. X times minus 2 is 2 minus 2x. Then 5 times 6x squared is 30x squared. 5 times x, you have 5x. 5 times minus 2, you have minus 10. So what we do now is we collect like terms. So 6x cubed stands alone. So for x squared, we have x squared plus 30x squared. Then we have minus 2x plus 5x minus 10. So simplifying this, we have x squared plus 30x squared. This becomes 31x squared. Then minus 2x plus 5x becomes 3x minus 10. So that's our final answer. I hope you understand what I did here. I hope you understand what commutativity is. Let's just do something basic. You agree with me that 3 times 2 is equal to 2 times 3. Same thing, 6. So that's what the commutative nature of multiplication is basically. Let's take one final example under this. Number 3. Let's try something larger. X squared minus 2x minus 3 multiplied by x squared plus x plus 1. So let's distribute this into this. We have x squared into x squared plus x plus 1. Then we have minus 2x into x squared plus x plus 1. Then we have minus 3 into x squared plus x plus 1. Now let's multiply. This becomes x squared times x squared becomes x raised to the power 4. X squared times x becomes x raised to the power 3. X squared times 1 becomes x squared. Minus 2x times x squared becomes minus 2x raised to power 3. This becomes minus 2x times x becomes minus 2x squared. This times this becomes minus 2x. Then minus 3 goes in. We have minus 3x squared minus 3x minus 3. Now let us collect like terms. So x raised to the power 4 stands alone. X cubed, we have x cubed plus x cubed minus 2x cubed. Any other x cubed term? No. So equal 1 to x squared plus x squared minus 2x squared minus 3x squared. Then let's move on to the x term. We have minus 2x minus 3x, and then finally our constant. Then simplify. X raised to the power 4. Then you have plus 3x cubed minus 3x cubed. This will give us minus x cubed. I hope you still remember what we did with our numbered lines. Please do not guess your answers. If you do not know how to perform this basic arithmetic, please use your number line, because just like your exams under this course is MCQ objectives. So you're going to have options, and then you miss the slightest things, you get your answers wrong. So let's move on. X squared minus 2x squared minus 3x squared. This will give us minus 4x squared. Minus 2x minus 3x will give us minus 5x and minus 3. This is our final answer. And like I always say, practice is what makes for mastery. Drop your comments, comment your observations, your difficulties, whatever you find difficult, comment. And also please share this with your other colleagues. Thank you very much. And if you have not subscribed, did I just say please subscribe? Thank you very much.